Okay guys, so here's another video I would like to film today. So this one is just a continuation of chapter 7. So earlier I did the one for 7-3 and now here's the one for 7-4. So 7-4 is about adding and subtracting radical expressions. So for the objective is about adding, subtracting radicals. So back to Algebra 1, I'm sure you guys know what that means for combined like terms. And that's right. So anytime that they do have the exact same variables, so that means the coefficient, we can either add or subtract. So similar situation regarding the first example here. So anytime that you see the similar or the exact identical radical, so you can always combine those coefficients together. So now let's take a look at like a few examples right here. So starting out with the first one, so we do have 6 root 3 minus 5 root 3 plus 2 root 3. Again, so things that they share in common, which is root 3. So basically what we can do, we can just combine all the like terms together. So 6 minus 5 plus 2, so then that would be 3. And then root 3, that's what they share in common, so it's 3 root 3. And now the way you can do this, we can always take out the greatest common factor, which is root 3. And then whatever the number that's remained, you can always subtract or add those numbers. So 6 minus 5 plus 2. So again, 6 minus 5, that's 1 plus 2, then that's 3. Root 3 times 3, which is the same as 3 root 3. Okay? And then for B, again, compare and contrast. We want to find out the similar element or the common factor that they share all together. So what we got here, we got x root 6, so that's what they share in common. So 5 minus 3 minus 2, so everything got canceled. We got 0 times x root 6, which is 0. Okay. So the first two problems, those are pretty basic. And now let's look at some of the rigorous or the challenging one, especially for D and E. But before we do D and E, let's look at that C first. And root 48, 3 root 27 plus 2 root 75. So for those people who might be wondering, they have nothing in common. Well, the reason why that they don't have anything in common because we haven't simplified those elements yet. Okay? So let's try to break that apart. Root 48, root 27, and then root 75. So 48, this one is written as 16 and 3. And then 27, that one is written as 9 and 3. And then 75, that's written as 25 and 3. Again, the way to come up with the structure like this, always keep that in mind. We need the perfect square number and the non-perfect square number. So perfect square number, non-perfect square number. Again, 25 and 3, perfect square number, non-perfect square number. So any number that coefficient we don't do anything about, so just simply bring those numbers down. So root 16, we do have 4 root 3, minus, so 3 times root 9, which is 3. And then 2 times 5, root 3. So you may notice that we got 4 root 3 minus 9 root 3, and then 10 root 3. And what do you guys notice? That's right, root 3, that's what they share in common. So 4 minus 9, that's negative 5, plus 10. So it's 5 root 3. And that's the final form. Now, what about for D? So for that one, we do have 2 cube root of x to the power of 8, y to the power of 6. And then minus 3y squared cube root of ax to the power of 8. And it looks like they have nothing in common. Well, again, we need to simplify the entire expression first. So this one is written as 2x to the power of 8 over 3, y to the power of 6 over 3. So what I'm doing, I just want to convert it from radical form to exponential form. Again, the formula that I'm using, the radical form to exponential form. And then the second term, 3y squared. So we got cube root of 8, which is what, 2. And then x to the power of 8 over 3. Again, cube root of 8 is the same as 2. So now this one is getting very close, so we do have 2x to the power of a third, y to the power of 2, minus 3 times 2, then that'll be 6, and then x to the power of a third, y squared. So if someone can tell me about things that they share in common, that's exactly right. X to the power of a third, y squared, x to the power of a third, y squared. So coefficient, we just subtract. So we got negative 4, x to the power of a third, y squared. So again, we're dealing with improper fractions. So back to the previous sections, what we talked about. So this one we can always convert it back to the mixed fractions. So we got negative 4, x to the power of 2 and 2/3. And now for the last step, we just want to categorize the perfect integer exponent and then try to separate it out with the rational exponent. So we got negative 4, x squared, y squared, so they're all outside a radical. And then the one that stays inside a radical, we do have cube root of x squared. And that would be the final form. And then for e, so we do have 9a square root of 20, a to the power of 3, b squared plus 7b, square root of 45, a to the power of 5, excuse me. So this one's 45. Again, it looks like they have nothing in common, so first thing that you want to do, so try to find a way to simplify the radical. So we got 9a. So square root of 20, that's considered 4 and 5, so it's 2 root 5. Again, square root of 20, it's like root 4, root 5, which is 2 root 5. And then a to the power of 3 half, b to the power of 2 over 2. So the second term we got 7b, root 45. So that 1 and 45 consists with 9 and 5. So we got 3 root 5. So 7b times 3 root 5. And then a to the power of 5 half. So it looks like these two have nothing in common, but let's try to simplify it a little bit further and see what happened. So 9 times 2 root 5, we got 18 root 5. So this one is a to the first power times a to the third, 3 and a half. So this one would be considered 3 over 3 plus 3 over, well, it's 2 over 2 plus 3 over 2. So for that one, we do have a to the power of 5 half. And then b to the power of 2 over 2, that's just b. So now for the second term, we do have 7 times 3 root 5, so 21 root 5. And then a to the power of 5 half, nothing we can do about it yet. And then b, just leave it. So once again, compare and contrast, you'll see that things that they share in common, which is root 5, a to the power of 5 half, and b. So for the coefficient, we just want to combine them. So 18 plus 21, which is 39 root 5, and then a to the power of 5 half, b. So now for that a to the power of 5 half, we can always convert it back to the mixed fractions. So we got 2 and 1 half. So let's just regroup them. So we do have 39 a squared, b, and then root 5 and a. And that's the final. So now let's look at something else, something that's a little bit more rigorous. So this one looks kind of like simple expressions with the radical, but there's certain things that you have to do. So we do deal with the fractions with the radical, and also it's being separated with the variable and the constants. So now let's deal with that f, g, and h. So anytime that you want to combine the fractions, make sure that we need to come up with the exact same denominator. So like the first one, so we do have two different denominators there. So one is 3, the other one is root 3. But before we find the least common denominator, there's certain things that you have to do. Okay, so start with f, root 3 over 3 plus 1 over root 3. So root 3 over 3, nothing we can simplify from here, so just leave it. The 1 over root 3, we can rationalize it. Again, multiply by root 3, top and the bottom. So we've got root 3 over 3. Multiplying fractions, we just multiply them straight across, so root 3 over 3. So now we do know that's the exact same element, so that means like 2 root 3 over 3. So again, nothing can reduce, nothing can simplify, so just leave it. And now for g, similar, so root x plus 1 over root x. If there's no denominator, it's always 1. So least common denominator, then that'll be square root of x. But before we do that, we need to rationalize the second term. So multiply top and the bottom by square root of x. So we got root x over 1 plus root x over x. And you may notice that 1 and x, the least common denominator, so that's x. So multiply by x top and the bottom. So we got x root x plus root x over x. Same denominator, so numerator, we just combine them together, so x root x plus root x. And for those who might be wondering, can I take out the greatest common factor? Yes, you may. So root x, so we got x plus 1 over x. Well, basically you can leave it either way, the standard form or the factor form. Okay, so now let's try g and h. Well, h. The last one. So that one is given as root 12 over 6. And then plus 1, well, root 1/3. And then plus root 3 over 3. So root 12, which is considered 4 and 3, so it's 2 root 3. Over 3 over 6. Excuse me. And then this one here is written as root 1 over root 3. Plus root 3 over 3. So for the first term, basically you can reduce it. So we got root 3 over 3. Second term, so this one, try to rationalize it. So we got root 3, top and the bottom. So we got root 3 over 3 again. Well, the third term, that's already written as root 3 over 3. So we got 3 identical terms. So 3 root 3 over 3. Then reduce. So anytime they see the radical with the variable, with the constant, with different type of structures, addition, subtractions, multiplication, division, no need to be freaking out. It's all about applying the property, either separations, rationalizing, using the formula, combine the like terms, or find the identical or similar structures. So thank you for watching the video today, and if you guys do like the video, I would like to subscribe to the channel. Thank you.